adding or subtracting polynomials. Just as before with, for instance, 3x plus 4 minus 2x plus 3, you can add and subtract terms if they have the same variables and same exponents. So let's try out the examples in this case. For a, we have 2x to the fourth plus 3x plus 4x to the fourth plus 2 minus 5x squared plus 6x squared plus 6. And notice I kind of spread them a little. That way we can tell the difference between which term is which. Agreed? So one thing we can do is either color them differently, underline them with different numbers of underlines, or think of them like different fruits. Agreed? So your choice on which one will help you the most, but I'll give you the options. So we can think of them, for instance, we have grapefruits, oranges, and mandarins. All three of them look similar, are similar in color, similar in texture, but they typically taste different, agreed? Or might be different in size as well. And apples, they don't look alike, right? But that's the last one in this case. So for example, if we have 2x to the fourth, let's think of those as grapefruits because it's the biggest exponent. Typically grapefruits are a little bit larger. 3x, we can think of those like mandarins. Those are a little bit smaller typically. And then we also have the negative 5x squared. That would be, for instance, the oranges, medium size, right? And last but not least, the numbers, constants, the 2 and the 6, would be the apples, agreed? Because they don't have an x, in other words. Since we can tell them apart, we probably wouldn't want to combine the grapefruits, the oranges, and the mandarins, right? We'd still sell them as separate fruits, agreed? And we would probably make different fruit beverages, maybe. That way we can tell the difference between them in many cases, other than trying to make a smoothie, then you might mix them together, right? So, in this case, we can also color them differently. Once again, there we go, different colors. That way it makes it easier to visualize. That's another alternate way of doing this. That we can combine the ones that have the same color, same exponents, right? Or underline them. So if I underline, for instance, 2x to the fourth plus 4x to the fourth, in other words, the grapefruits, or the blue colored terms there, the ones that have the exponent of 4. So combining them together, 2x to the fourth plus 4x to the fourth give us 4 plus 2, 6. 6 boxes of grapefruits is the way to think about this if it makes it easier for you. Okay, so we have 6 boxes of grapefruit, 6x to the fourth. And up next, something I like to do before I go to the next one is I like to cross them off. If I've added them, I combine them together, I'll cross them off. That way I'm not tempted to by accident combine them again. So there we go, I crossed them off. That way I know I combine them together into 6x to the fourth. 6 boxes of grapefruits is all that we have together. We're accounting for them. Okay, up next, since we're writing them in decreasing exponential order, highest exponent is the fourth, followed by 2. There's no 3 exponents, right? So it's exponent of 2. So negative 5x squared plus 6x squared n. So let's put 2 sets of lines, or underlines, to tell them apart, right? So if you have no color markers or color pencils or color pens, you're welcome to put multiple numbers of lines. So 5x squared, or negative 5x squared plus 6x squared. 6 minus 5 gives us 1. So just a box of oranges then, or x squared. So we have x squared. And there we go. I'll cross them off. That way I don't combine them again by accident with something else. And up next, let's see. 3x. It looks like the mandarins, right? There's only 3 boxes of mandarins and there's no other combination of them. So we have a total of 3 boxes of mandarins plus 3x. Followed by, let me not forget to cancel that one out, right? So I didn't put an underline since there's no other one like it. Last but not least, the 6 and the 2. Plus 2 plus 6. Do notice, I do not have an equal sign. So I should not be changing the sign on any of those terms or numbers. The sign always remains the same, and I want to avoid writing an equal sign because that makes me think I have to pass through the other side, and all of a sudden I will change the sign by accident. No sign change, agreed? We're just combining them or adding or subtracting. So 2 plus 6 gives us a total of 8. So we have 8 apples. 8 loose apples, right? There isn't a full box, it's just 8. And let me cancel them, and notice that I canceled everything, so I combine everything together. That would be my final answer as far as I can tell, because I have 6 boxes of tangerines, that's the 6x to the 4th. I have a box of oranges, that's x squared. And I have 3 boxes of mandarins, 3x, and 8 apples, or just the 8. So 6x to the 4th plus x squared plus 3x plus 8 would be my final answer. Notice we have them in decreasing order. Highest exponent is 4, next exponent is 2, and the 3x has an exponent of 1, but we typically don't write it. Similar to not writing a 1 in front of the x squared, because it's the constant of 1. Okay, so let's circle our answer and go to the next one, B. So for B, we have a set of parentheses with negative 7z squared minus 4zv plus v squared. Notice I kind of separate them a little to be able to notice the difference between the terms. We have a negative between the parentheses, so another set of parentheses with negative 5z squared plus zv minus 6z squared, close our parentheses. Now let's realize, do I really need the parentheses on the left side? Is there anything being multiplied or divided outside of the parentheses into the parentheses? No. But before I do that, can I combine anything within that parentheses? Let's see. Negative 7z squared, there's no other z squared. And negative 4zv, there's no other zv's that I can combine there. V squared, there's no other v squares that I can combine there. First set of parentheses, I cannot simplify. But I don't really need the parentheses. Be aware of that. There's nothing being multiplied to it. Next set of parentheses. Do I really need the parentheses? Technically I do, because there's a negative there. Remember, you're welcome to put a 1 after that negative, or between the negative and the parentheses. Now we can realize that we're distributing a negative 1. So you can either distribute a negative sign or distribute a negative 1. And let's realize negative 5z squared, we can combine it with the negative z squared. So missing 5 boxes of oranges as a reference, and then we're also missing 6 more boxes of oranges. We can combine them to say we're missing a total of 11 boxes of oranges, or negative 11 z squared. So let's do that. Let's get rid of the parentheses from the first set of parentheses since we don't need them, and let's combine the z squares in the second set of parentheses. So there we go. First set of parentheses is gone because it doesn't really need to be there. It's just for reference. And the second set of parentheses does need to be there because there is a 1, right? Notice we combine negative 5z squared minus z squared, 6z squared I should say, and that gives us a total of negative 11z squared, and then we still have the zv right next to it. Note, we did not change any signs yet, agreed? Since we're just combining, they were both negative, so they still are negative 11z squared. Now let's worry about the signs. We're distributing a negative 1, agreed? So distributing and getting a negative 1 on there. Let's realize negative 7z squared minus 4zv plus v squared. We can't do anything with it yet, so we just got to bring it down. There's no common terms there, so we just bring it down. Up next, distributing the negative 1. Negative 1 times negative 11z squared. Negative times a negative, that's just going to be a positive. So plus 11z squared. And negative 1 times the zv. Well, we can always put a 1 if it helps you visualize that. Go for it if you want to put a 1. 1 times 1 is still 1, but negative times a positive, it's a negative zv. So there we go, we simplified it. And now, are there any like terms? Yeah, there are some like terms. We have z squares, and we have zv's. So combining those, negative 7z squared with 11z squared gives us 4z squared, agreed? So we combine those two together, or cross them off, that way I don't combine them again by accident. And let's realize decreasing order of exponents, so z square is an exponent. Next we have the v square, so let's just write it down, there's only one of those. So plus v squared, and I'll cross it off since I don't want to use it again by accident. And now we have left negative 4zv minus zv. Combining those, they're both negative, right? So if I borrowed 4 of them and then I borrow 1 more of those, there's a total I'm missing of 5, or I totally borrowed 5 of those. So minus 5zv is the combination. And I cross them off to notice that I've combined everything. Everything else has been crossed off, so that is my final answer then. 4z squared plus v squared minus 5zv. Notice I can't combine any of those. None of them have a z squared or a v squared. Agreed? So that would technically be my final answer. Let's circle it before we forget, right?